Yo, yo, yo. Here is the last part of the homework for last night about the investigation on quadratic functions, summarizing the math. And the first question was, what does the sign of a in a quadratic function tell about the graph of the parabola? And that's the key word here we're looking for, is the sign. Well, there's only two signs, a plus or a positive and a negative. Okay, so if you don't see a sign, you are assuming that it is plus. Okay? It is positive. So when you have a positive, this is going to keep the shape in the original location. In other words, the shape of the parabola will not be reflected in any way if it is a positive in front of this A. Okay? Likewise, though, if you have a negative in front of the A, what it does to your original parabola is it flips it over the x-axis. So what do they tell you about the graph? They tell you whether it's being reflected over the x-axis or not. Okay. Part B, describe how the absolute value of A. I hope this isn't a new term for you all. But this term here, absolute value of A. Absolute value means the distance a number is from 0. And if we're measuring distance, you're not really concerned about positive or negatives. You're just worried about the actual distance. All right, so if you have a graph here, and if the original one, was supposed to look something like this, very sloppily drawn. That is 0, 0. Okay, when you put a 1 in for x squared, if you put a 1 in, 1 squared is still 1, so 1, 1 should be on your graph. 2, 4 should be on your graph. It actually should be somewhere like right here. That's pretty close. Okay, so if that's your original, and if the value of A gets larger than 1, if it gets larger than 1, let's say we put in like a 6x here. So what that does is that takes the original and squares it. If you put in a value for x here and you square it, it also then multiplies it by 6, which means that your graph is going to be super tight to the y-axis. Okay, so and it's going to be, if you were reading this graph from left to right, it will be increasing much more rapidly than our original one here. So when A gets larger, it sort of thins it out closer to the y-axis, and it moves in a much quicker pace, I guess, if you will. It accelerates much quicker than these guys. Okay. Okay, and then likewise, if you have a graph that has a number that is smaller than 1, so those are your decimals and your fractions. Let's say it's 1/6. And you try to plug in a number here like 1. Well, 1 squared would still be 1. And then you take a 1/6 of 1, which is a 6 times 1, which is still 1/6. Okay, and so what happens here is that this guy's fattening out a little bit. Okay, so when you have a number that's smaller than 1, it's not going to change as quickly as this guy up here did. It's going to change slower because it has widened out. So that's what it's talking about, the absolute value of the A. How does it affect how it gets larger, how it thins down and stretches up, or how it widens out and stretches horizontally. And then the last question, or if you want something nice and pretty, I guess this would maybe be a better answer if you're looking for something pretty specific, but what I explained is basically what this statement said here. And then for C, what does the value of C tell you about the graph? What key feature does it represent? And so we, back here, that was one of the same questions for number 3. If you watch that video tutorial, what does C represent? And it just was representing the y-axis, where it crosses the y-axis. Alrighty. See you on the next one.